So, the first task that we will do, which I will call as week 4, sorry, this will be week 5, which is a speech part. Okay. Week 5, so speech experiment 1 we will try. Okay. In this experiment, our goal is very, very simple. Okay. We want to identify, given the speech signal, the language of the spoken speech clip. Okay. So, the task is, given speech signal or given as audio clip, identify the language. Okay. This is all. So, it is called language identification. Okay. Why is this useful? Okay. So, for example, if you are getting you are doing a you want to call a customer service. So, as soon as the call picks up, it will say welcome to whatever it is, Airtel or Jio customer service. Hindi ke liye kripya ek dabaye. For English, press 2. Okay. So, if let us say we have 22 official languages. So, we cannot keep saying press 3 for or Tamilku moondrai ayuthavum. Whatever, I can't speak other language. Okay, Kannada for example. Kannada ke liye Kannada ga nalakne idu press maadi, something like that you have to say, right. So, you cannot keep saying for all the 22. By the time you finish the 22 presses, you would have actually the customer would have given up, right. So, then what you do? You do some kind of another technique which actually also involves speech, that is called speech recognition. So, nowadays they will say which language would you like to speak in, right. But that message, right, if an elderly person, I do not know English for example, so I cannot say please say your language as English. If it is English, Hindi mein baat karne ke liye Hindi bataiye, that also is difficult. So, if a person is not familiar with Hindi or English and I know only Tamil, it is not clear to me what I have to do. As soon as I pick up Hindi for English, say English, I can speak the thing, or they can say simply speak the language, but if I do not know English, I am not clear what the message is, right. So, if I just start speaking, can you automatically detect the language so that you can then appropriately send the mic call to the appropriate agent who can speak your language, right. So, based only on the audio clip, without me telling you whether I am speaking English or Hindi or Tamil or Kannada or Gujarati, from the audio clip itself, as soon as I start speaking, enakku Tamil, enakku Geo Center. So, as soon as this comes, can I detect that the person is saying something in Tamil and then go to a call agent who knows Tamil to help you out, or mujhe मेरे अकाउंट के बारे में जानना, so immediately you figure out it's Kannada, or ನನಗೆ ನನ್ನ account something like that, if somebody starts that's Kannada, so you switch to Kannada, right. So, this is a task we want to do. So, given a basic audio clip, can I basically do something about language identification? Okay. So, this is basically a pattern classification problem. So, the task is very simple. So, we have some audio clip which is a speech signal. In practice, this continuous time speech signal will be converted through an analog to digital conversion to a sequence of numbers. Okay. So, this is all some sequence of numbers that will be fed into a computer. Now, I want, given this thing, some big classification system, okay, which will tell me which language I have spoken in. Okay. So, language output. Okay. So, given the speech signal, the desired output is, it should say Hindi or Tamil or Telugu and so on. Okay. So, this is what we desire to do. Okay. Now, how do I go about building such a system, right? So, just to give you an analogy, this is, all of these come under broadly pattern classification, that is all, right. So, this is just a pattern classification problem. Okay. So, here given the pattern of speech signal, I have to identify, classify it into Tamil, Hindi or Telugu. Okay. Just to give some analogy of how this task is, Suppose I have the heights and weights of persons, okay, and I measure the heights and weights of all children, right, some women and some men, okay. Why am I drawing it in some sort of a diagonal fashion? The reason is children are generally shorter and also less heavy, therefore, they will be in the smaller, in this portion of the signal, right, in this portion of the class, okay. Women are generally taller, more taller at least than children, but usually are shorter than men, and therefore height and weight are correlated. A tall person generally tends to be heavier, right. So therefore this pattern of going from, you know, this kind of a directional correlation exists between heights and weights, okay. So now I have three classes, okay, and here this is basically a measurement where I have actually recorded not only the height, weight, but I also know the class. I know in this case the blue X's are children, the green circles are women, and the light blue rectangles are men, okay. So this is called labeled data, okay. Okay. So this is something like data collection in which I know all the labels of the data that I am collecting. Now if I have an unknown height and weight, somebody tells me this is 5 feet 5 inches or 5 feet 6 inches and 72 kgs, right. So this is a measurement that somebody, I can't see the person, but I say I get the measurement 5 feet 6 inches and 72 kgs. Now based on these measurements, can I identify the person, or can I identify whether it's a man, woman or a child. So this is a pattern classification problem, okay. That is essentially what we are trying to do, okay. Right. So what we do is, there are two steps in any of these machine learning ideas or any of these pattern classification problems. One is called the training step, okay. The other is called the inferencing step, okay. Okay, or the testing step or evaluation or whatever you want, okay. So you might call this as also a testing step, okay. So what does that mean? That during training I have this labeled data and the measurement. From that I want to capture some aspect that differentiates or is identified with a man, a template for a man, a template for a woman and a template for child, okay. And the easiest way to build a template is to just take the average of all of these male measurements and put one the average, so I will put a different color here, one average value which is that pink circle, which identifies the representative male for that particular set of measurements, okay. How do I get the male? Because I have the label data, I take all the male measurements and just take the average of the vectors, okay. Similarly, I can go and identify the average female measurement, and similarly I can go and measure the average children measurement, okay. So now I have a representative vector for the child, a representative vector for the woman and a representative vector for man, okay. Now let us say this is my test data. So now I don't know whether that's a man or a woman or a child, okay, and my pattern classification problem should tell me what that whether it's a man, woman or children depending on the measurement, right. So therefore let's say this 5 feet 6 inches, so it's somewhere here, let us say. So 5 feet 6 inches is at this particular point, and 72 kgs is at this particular point. Okay, this is 5 feet 6 inches and 72 kgs. Now you know visually what that class should be, because it is closest to the pink circle, closest. That is our measurement of closeness between the test data and the template or the pattern that best represents each of the classes. And in this case you see that the 5 feet 6 inches 72 kgs is very close to the pink circle, right, as opposed to the distance between these two guys or the distance between these two guys, right. So it is furthest away from child. So it's very rare that a child will have a measurement of 5 feet 6 inches and 72 kgs. When I say child, let's assume everyone beyond under the age of teen, okay, so less than 13 or something, okay. And when I talk about women, I mean, so teenage we can have a separate class if you want. Then a woman is generally, there are some women who may be 5 feet 6 inches 72 kgs, but it's more likely to be a man, okay. So in these measurements or in these testing that I do, I might make some errors. So these are not actually not completely error free, depends on the data, right. So there's always a chance that I will make errors, and a good system is one that reduces the number of errors. So all systems will make errors, all machine learning algorithms, there will be some element of error. How much that error can be reduced depends on your creativity and how you can reduce it, okay. So now coming back to the problem of identifying, given the speech signal, I am given the speech signal and I have to identify the basic language that is spoken just by the audio clip, okay. This is what I am planning to do, okay. To do that, here I was using in the analogy to the heights and weights. So the height and weight were two important measurements that I used to distinguish between a man, a woman and a child. So these are called features, okay. So I have to use some features which help me distinguish between a man, woman and a child, okay. So some features are useful for distinguishing, some are not useful for distinguishing. For example, if I look at the skin color of somebody, that is not going to help me distinguish between a man, woman or child. So that feature is not very useful. Or if I say I know the language that the person can speak, that if I know that that person is a Hindi speaker, that is not good enough for distinguishing me between a man, woman and child, because a child can also speak English, Hindi, a woman can also speak Hindi, a man can also speak Hindi, okay. Of course, when I speak Hindi, in my voice there is a characteristic of age, that I am not worried about, but just using the identity of language spoken is not good enough for me to identify whether it's a man, woman or child. But height is a very good feature that tells distinguishing characteristics between a man, woman and child. Weight is another distinguishing characteristic, right. So we have used heights and weights. So first thing that I need is, given the speech signal, I need to extract some features that will help me distinguish languages, okay. This is one thing. Okay. Secondly, what else do I need? I also need some kind of a measurement. So I need some kind of a classification system which I have to train. So that is what we are using label data to train, such that given this feature, I will try to find out in this feature is the input. Because it's label data, I know that that particular clip came from Hindi, I know another clip came from Tamil and so on. So in the train data, I will have labeled train data, right, labeled train data where audio clip 1, I will know it's Tamil, audio clip 2 I know is Telugu, audio clip 3 is again Tamil, audio clip 4 is Hindi, and so on. I'll keep generating audio clips and have the corresponding labeled train data. Then I build a classification system which will be trained to minimize, at least for the train data, the error that it produces. So basically I will give the first input audio clip 1, I will pass it through the classification system, it will make some output, it will give me some output, it may be correct output, it may be wrong output. If it gives me the wrong output, I will back propagate if I am building a neural network, or if I am using some other distance measure or some other criteria, I will then use that error to adjust my classification system so that my next prediction of the train data improves, and I will keep repeating this training process until I am able to, on the trained data, get reasonably good performance. Okay. But we also often test it on some held out data which is called the valid data. Okay. So there is also a separate set of data called valid data, where when I am training the system, I want this is held out, it is not part of the training data. So this data is not seen while I am training, or it is not used in improving my system. So if I get a separate data, I am trying to check how well my system is adapting or generalizing to some unseen or unencountered data, and how good a job is it doing. If this part is also improving, I know that it is sufficiently generalizing, and therefore when I give real inferencing data, right, during the inferencing step or the testing step, I will get this reasonably good performance. And if I build a more better system, the performance will improve, which means I will make lesser errors. Okay. So this is what I am going to be showing you through a small collab exercise, okay, where you will build a a classifier that will distinguish between 3 languages. Okay. I have specifically taken something that is easily available on Hugging Face. Therefore, we will talk about some Western languages, but our own lab works a lot on Indian languages. So you can actually, we will try to put some data as an exercise for you, where you might want to distinguish between 3 Indian languages or 5 Indian languages, whatever you want. Okay. So first we will try to do it in the standard collab Hugging Face kind of setup. Already Professor Mitesh would have talked to you about how to load data sets in Hugging Face, how to tokenize them. There are various aspects that you would have dealt with. I am assuming that you have some familiarity with all of these, and therefore you will now try to build a system that, given an audio clip, you will try to identify what that language is. Okay. I am taking an example of Western languages. So in our particular case, the problem that we will address, right, in collab is this: you will be given a Hugging Face data which has audio clips from many languages, okay. What you are going to do is you are going to take 50 audio clips of English, okay, 50 audio clips of Spanish, and 50 audio clips of Romanian. Okay. I mean, I can choose any of those languages. the Hugging Face database as a data set has large number, we will also try to put on Hugging Face some Indian language data sets, so that if you want, you can test it out on Indian languages, build your own system to identify Indian languages. Okay. Then now this is my training data, because which is labeled, right, training data which is labeled. Okay. So I know these 50 audio clips come from the language English. So the label is there. This audio clip is English. First audio clip English. Second audio clip English. This audio clip is Spanish. This audio clip is Spanish. So I have label data. Then remember, once I am trying to do pattern classification, I need some features, okay, which is also called as representation, right, that helps me distinguish the three languages. So from the speech signal, can I extract some features? In the case of height versus weight, from the human I extracted the height of the human, the weight of the human. So these were two measurements that I extracted and used that to classify and identify whether it's a man, woman or child. In this case, what are those features? Okay, there are many ways. We have some previously, before the deep learning methods came, we had some other easier or simpler methods, but nowadays we have a little more powerful neural networks to extract some useful information that will help me distinguish these classes. So we will use some neural based representations, okay, and this is exactly analogous to what happened for representation of words or byte pair encodings and so on in the text processing. You would have used BERT, right, to get some useful representation, right, for words or whatever, right. So the BERT basically is a huge neural network where you got some useful representation for each of the words, right, in the context that you are dealing with. So similarly, in speech there are, so BERT is again some kind of a pre-trained model, okay. Okay. In speech also we have multiple pre-trained models with different objective functions. So in speech, one good pre-trained model that exists, right, and people have pre-trained it, this in this case Facebook and Meta, they have pre-trained it and put it in the public domain, and this is called wave to vec 2.0, okay, model, okay. So this is a speech model, it is a big neural network that is useful for extracting speech representations. Okay. So now that I have these, so what will I do? Given the audio clip, I will first have to extract the features, which means I will pass this audio clip through this deep neural network, right. This is a neural network, and I will get some vector or speech representation, okay, which corresponds to the, if it is coming from the English audio, this vector representation will correspond to the speech or representation for English. Similarly, for Spanish, I will get a representation for Spanish. For Romanian, I will get a representation for Romanian. Okay. Now, these are basically a sequence of vectors. So, what you will get is basically, given the speech waveform, you will pass it through the wave to vec. So, for each vector, you will get some kind of a sequence of vectors, sorry, for each signal. So, this is the time axis, okay, and we will just take the average of this vector, and this will be the average vector, okay. So, and then this is the representation, and this is basically my label, it can be English, okay. Next, if the audio clip, the next audio clip, sorry, can I squeeze it here? If the next audio clip happens to be Romanian, I will pass through this again you will pass through this same vector, wave to wave neural network, and then I will average and get a vector, and then this will be called Spanish. Okay. So, this is the train data set that I will create. Now, I have to do some kind of a representation for this. So, I am going to use some ideas of closeness, or in this case I will have a neural network, another neural network, to basically classify these guys. Okay. So, I will talk about that neural network next. Okay. And so, let me just show you the steps that I am going to be doing, so that you have clarity in how to go about doing it. Okay.